Hi guys, welcome back to a new video. So in this video, I'll show you quickly how to create a simple generative AI application specifically which is there for invoices named as Invoice Data Extractor, and it will be done using watsonx.ai, basically a solution by IBM itself. And I'll be leveraging a couple of models that I'll be talking about as well, like specifically from Meta's point of view. So without wasting any further time, I'll show you quickly how this entire application will be working and why invoice. So yeah, so before going into the architecture diagram, I'll tell you why invoices is something which invoice extractor can be one of the good projects that you can work upon, or probably it can be a good solution to, sort of brainstorm upon, because in every field and in every vertical, invoices keeps on getting generated, and companies are now looking for easy to leverage solutions which can basically extract data from this invoices. Now this invoices can be of varying formats. It can be simple images, of handwritten notes. It can be PDF files. It can be images of different formats, JPJ, PNG, JPEJ, whatever it is. So now it becomes a difficult task to extract informations from all this kind of invoices, and that's where we can apply the generative AI capabilities in order to extract the data using the OCR, or the optical character recognition capabilities from the various LLM models, and then respond or provide or extract the data out very easily, and then give the accuracy scores to provide the users that I'll say that assurance that the solution is quite capable. At the same time, you can also uh, take the informations and deploy it in certain formats, and then sort of upload it, or let's say store it into SAP applications or any kind of application that the customer is already having in place. So coming to this architecture diagram, you can see on the left hand side that there is a user first of all. So first of all, this user will provide an input on the user interface, which is created using the Streamlit application on VS Code. And once the person goes onto this user interface, there is an option to upload the kind of data that they want to extract the informations from. Basically, it can be an image that is of JPJ, JPEJ, PNG, or even a PDF file. Once the file has been uploaded, basically what happens is that, utilizing the API capabilities, what we have done is that we have connected the dot with watsonx.ai, that is IBM solution, which is a single platform which is capable of having traditional generative AI as well as agentic AI capabilities. So once it is presented on the watsonx AI platform, basically, then the process starts. Basically, it's connected to the foundation model. Specifically over here, we'll be using Meta's LLaMA 90 billion vision instruct model. I'll be talking about it in the upcoming uh, slides, or probably in the code itself. So over there, we'll be using that vision model, and then utilizing that vision model, we'll be extracting the informations using the API keys, and then we'll be providing it in the form of text, which can be then downloaded very easily. Which again, this option will appear on the Streamlit app, and once it appears over the screen, the person or the basically the user can easily view it, download the the text file, and leverage it as per their requirement. So that's as simple as that. Let me now take you through the basically the code first of all. So yeah, so this is the code. Basically, you can see that I have first imported the Streamlit package, and after that we have imported something called as request. So Streamlit is for the user interface that we'll be building, that I'll be showing. It's nothing fancy, it's a very simple thing that I've created. Reason being, I wanted to show you the capabilities and not the fancy UI creation part. So yeah, so basically you can import the request over here. Request basically will be like handling the HTTP sort of request. For that we have this particular package. Then for the base64 part, so basically if you have any kind of image which is present in let's say byte formats, then in order to convert it into base64 for the embedding purposes, I've used base64 package. The IO part is basically for the embeddings as well. So basically it uses the in memory, like the embeddings, basically to then process the files that we'll be working upon. And then we also have PL basically for dependencies. Let's say if there's certain PDFs, if we need to convert it to images, that does not happen, then we can use this package called as PIL. or pillow packages for making that conversions. And over here I have hidden certain keys. So will be using the API key, the project key, the model ID, IAM, URLs. So these are specifically for IBM case only, because I'll be using watsonx.ai platform. So all this data that you can see on the screen, the highlighted ones, we need to have it in place. So keeping this aside, I'll show you exactly how you can find out this informations from, and how you'll be able to extract the data utilizing watsonx.ai in some time. But let me explain you the code first. I'll just give you a very eagle-eyed view on the entire code, just to give you a heads up. And at the same time, I'll be uploading this particular code in my GitHub repository, and I'll be providing the link also in the description box. So don't worry on that. So basically, I am over here. I have set up the Streamlit application that I have basically created. So the title is handwritten, extractor layout is centered. Uh, I have named it as invoice OCR extractor. Over here, we can upload the file in terms of PNG, JPG, JPEJ, and PDF, as I've spoken before as well. uh, then I have given certain prompts that the model, I mean, basically the solution needs to follow. And the particular LLM model that I was talking about, that is Meta's LLaMA 90 billion vision model, it will be following these instructions that I've provided in the prompt part. So basically, I have added over here that the invoice headers and titles needs to be extracted. Certain line items have also to be provided, like let's say description of the uh, sort of the product that you are talking about, the quantity that it is present in, the unit price, subtotal, any sort of tax that has been added onto it, or total. So now obviously you can also customize it as per your own needs or as per your customers' requirements. You can do that. Over here, I have given certain instructions as well. You can have a detailed look into it as well once you go through the GitHub code. But I have asked them to preserve the alignments and numeric digits and everything. Whatever is present over there, it needs to be presented in the same format. So after that, I have also provided a total summary part where the application then will give you data on this particular format, like subtotal, tax, discount, grand total, currency. If it is shown, let's say if it is in dollars it will show. If it is in euros, then it will be showing it in euros. If presented in rupees, then so on and so forth. So it will show that. After that, it will also ensure to extract the key fields like invoice number, PO numbers, invoice date, and it will do that things in a very minute format. It will ensure that the accuracies are at on point. Post that, it will also provide you the metadata and accuracy reports. For the metadata and accuracy report, it will follow this kind of format. Let's say it will include this block, which is document type. It can be an invoice, receipt, etc. It will show that. If it is not present in, I mean, which language is it present in? If it's not in English, then what is it? If English, it will show English. If it is French, then it will show French. German, then German, so on and so forth again. Post that will give us the quality of the image, whether it's of what quality as per the LLM model. If there was any kind of handwriting legibility over there, it will show that okay, it is clear, mostly legible, or illegible. It will give that kind of details. It will give us the confidence level, whether it is confident upon the the data that it has extracted, whether it is of medium accuracy, high, or low accuracy. It will also give us the detected handwritten regions. So how many spots in the invoices, or how many places within the invoice image or the file, basically the handwritten parts are there. So it will be able to extract and give you that rough estimation of those parts that it has also extracted the data from. Post that will also give you informations about the printed text accuracy, also in terms of high, moderate, and low. It will give you the accuracy scores as well in terms between 0 and 100. So the OCR accuracy score also will be provided, and it will be provided without any kind of percentage sign. So if it shows 99, then understand it's 99% accurate. If it shows 30, then 30% accurate. Accordingly, you can understand it very easily. So that will give them the customers basically an idea that what's the OCR capability, or what's the confidence score that the model has been able to derive out of that particular invoice after extracting the data. So over here I have extracted basically the tokens. Let's say using the IAM or the identity access manager URLs, it will extract the informations like the API keys and everything. If those things are not in place, like say the IAM token is not in place, that will show you this error saying that IAM token error. It will show that access token, and then it will give you an error again. Post that, for, let's say, the PDF to PNG part. So what I've done is that llama, these 90 billion vision models at times might not be able to extract properly from the PDFs. So I have converted the PDFs into PNGs using the PDF to image part, as well as PYMU PDF, this one. So I've used these two packages. If this does not work, the PDF to images, then basically what happens is that we have PyMU PDF. So utilizing both this kind of like, let's say, packages, the PDFs can be easily converted into the images, and then these images can be used to extract the data from very easily using the vision model. After that, we can extract the text very easily. So as I told you before, that the image bytes can be converted into the base 64 encodings, and then we have extracted the data using watsonx.ai's LLM model. So again, I have done so. If it is a text, then it follows the prompts. If it is an image URL, it will take those data from there. uh, and after that, we can also provide the OCR scores. So that is basically done by the LLM model itself. So basically, we once the model scores have been extracted, it will check whether the values are between 0 and 100. If it is only between 0 and 100, that it always has to be, so then it will provide us the value. If not, then it will return nothing. So the value has to be between 0 and 100. Post that, we can upload the file. So this is the Streamlit application part where I've written the code for uploading the file. If it's a PDF, then we need to convert this and go to this particular like, let's say, this uh, particular function, and it will convert the image, and it will follow the instructions over there. If it's an image, then it will go for this kind of function. After that, it will have different options. Whether if it's not none of the formats, then it will give you an error over there. So for that also, it will give you that option. And lastly, it will give you option basically to download the informations as well. So it will follow the markdowns and everything, and it will give you a download button where you can download the informations in the txt format. So now obviously you can connect it to any kind of SAP applications or any other applications that the customer is also using, and then it will be able to extract the data in that particular format. So that will require a little bit of more work, but then that can also be done. So now let me show you that application first of all. So I will be running it on VS Code itself. So I already have a virtual environment created, so I'll not waste any time, and I'll show you exactly how I have worked on it. So the main application is app2.py, because that's where the API keys are in place. The app3, as you can see over here, I have hidden those keys because it is essential and it might charge me some amounts. Although it will not right now because I have used the free instance, but in general, ensure that this API keys and project IDs or whatever this informations, all these informations are hidden, because if utilized or if seen by anybody else, then they can basically utilize the same credentials and you'll be charged for it. So be little bit aware of it. Okay, uh, let me see. So let me activate this virtual environment within which all these files have been created. It's done. Let me run this Streamlit app now. Streamlit dot, okay, Streamlit 1.2.py. So once I do this, uh, basically what it will do is that it will go to the Streamlit application. This is as simple as it is appearing on the screen, nothing fancy. Sorry for that if you were hoping for something really crazy. So that's not what I've created right now. So pardon me for that. So over here, let me do two things. Let me also upload PDFs and let me show you the invoice as well. So let's say if it's a handwritten invoice, let me open this. Okay, you can see this is a handwritten invoice of two brushes, baby oil and baby powder. Let us see whether it's able to extract the data using the OCR capabilities or not. So basically over here we are using LLaMA's 90 billion vision models behind the scenes, and using that and the API calls, which is using which it is getting connected to watsonx.ai application, it's able to provide us this data. As you can see over here, it has extracted the informations very nicely. Olan's prescription center, prescription exclusively, whatever it is, center exclusively. It's able to find out all these details as well. Okay, this details it's able to fetch very easily, and then the datas. Okay, so yeah, It's able to do all those informations and then give you the OCR confidence score. So let me do it for some other file. Let me show you for let's say a hospital invoice image. Okay, so even in hospitals you have a lot of invoices that are getting billed every now and then, and let's say if you want to extract the data from this kind of complicated formats, then you can also do that very easily. So over here you can see that it's able to find out the details like Eliana Health, Eliana Health, billing questions, please call us so and so. All these informations are written over here. You can see, okay. So it's able to extract those data. So address Jendo 123 any street. It's written over here somewhere. Yeah, see address C, and then uh, health PO box, whatever numbers it is showing. Uh, line items it's showing as well. You can see the three line items. It's able to fetch the details very accurately. Uh, so grand total is $419. Subtotal tax discount. Currency is USD. Amount paid is this much. Additional key fields, invoice number is not there, so it's not able to provide. PO number is not there. So I was doing it for some other application, but just I mean some other type of kind of invoices, but just to show you that it's able to also extract data from healthcare kind of receipts, I'm showing you this. So invoice English, image quality is fair, mostly legible. Then the confidence level is medium, detecting handwriting regions is 5, printed text accuracy is high, moderate, high. Yes, the OCR accuracy score for this place is also 88. Yeah, so it's able to do this very nicely. Let me show you for another kind of file. uh, I think I have a PDF also in place. So let's say if I have this PDF and I want to extract this information from here, then whether we are able to do this or not, let's see. So I showed you with the JPJ or JPEJ format, which is basically the image formats, and now let me show you with the help of the PDF also. So as it's a free instance, it's taking couple of seconds to provide you this information or fetch the data. But in general, it will take couple of, I mean, it will take fraction of seconds to give you this response. So as the, uh, the payment type over here is euro, so it's showing euros, and it's able to extract all the data, gives you all the informations. So there are no seals or stamps over here. That's what it's showing as well, and then it gives you the accuracy score as well. So there are no handwritten mm, regions over here. That's the reason it's showing 0. But if it was showing any kind of handwritten kind of places or regions over here in the PDF or even in the images, it will give you that particular information as well. So yeah, that's how simple the application is. Once you get these informations, you can download the txt file. It will appear, and which will appear very easily, and then you will be able to have a look into it. Okay, so you can now sort of fetch these details and then store it in any format that you want to, or you can directly connect it to with the SAP application or any other application that your customer is having in place or you are trying to have. Then you can do that as well. And if I talk about the what's the next application, then this is the application that I was talking about. uh, if you don't have access to this application, don't worry. If you want to create the same application that I've created, so for doing that, you can just go to watsonx.ai, right? Free trial. uh, so once you are here, basically you can just use your personal credentials. You know, make sure that you don't use Frankfurt but use Dallas. You know, that's my personal recommendation. Go for Dallas and then log in using your personal credentials. It will work very easily. It will give you 30-day free trial and then you can experiment. But ensure, just remember that it has limited tokens in place. So be very careful of where you're using how many tokens. Once you complete the cap, you won't be able to leverage the capabilities of the LLM models. So you can click on open prompt lab, and over here this is the model that I have used, the 90 billion vision instruct model. And but there's a vast variety of models that is there in the display. You can choose any one of them and then create your application. But for me, 90 billion one was working the best, so I've used that. And if you talk about the API keys and everything that I was showing before, so to do that, you can click on view code and go to Python. Over here, you can see the URLs that you need to copy and paste in the designated spots that is there on the Python file, basically, which I'll provide in the GitHub. So do so. And then if you scroll down, I will not show you, but there is again the API key and all those details. Once you scroll down, you can see those things. So you can take the information from there, go back, and let's say if you for doing all these things, first of all you need to create a sandbox environment. So this option will come over here only. Over here there is an option to create a sandbox environment. Only once it's created will you be able to opt for any of these options. And if you want to check your project ID, once again click on the sandbox environment or the project box ID that you have created. For me it's John's sandbox, so I can copy the project ID from here. If you don't have the API key in place, then you can create the API key, click on create API key, name the API key something. Let's say I can make it OCR boss, for example, and then don't need to do anything else. Click on create. It will create the API key. Just download it if you want to, and then utilize it. You can copy from here and paste it on the code as well. Both works fine. And yeah, now you have created your application, the first application that you can work with. Thanks for watching this video. I hope that this particular video was useful for you guys, and I'll catch up with you guys in the next video. Until then, keep reimagining data with AI, and if you like this video, then ensure that you are subscribed to the channel and like this video as well. Thank you. Have a great day. Bye bye.